Hey guys, welcome to another Flutter tutorial. In this video, we'll be looking at a basic introduction to creating a backend for your Flutter apps. If you're a Flutter developer and you have knowledge of how the backend works and can create your own backend, that's a huge bonus for persons when they are employing you or just for when you're working on your own Flutter projects. It means therefore you can create your own backend along with your Flutter apps, and you will not have to depend on Firebase for the most part, as oftentimes is the case with Flutter developers, where they create the apps but they use Firebase as the back end. So here we'll be looking at the basic building blocks, the foundational elements that are involved in creating a backend, so that you guys can have this knowledge and can build on it to become your own backend developers when creating your Flutter apps. For this demonstration, I'll be using Nodejs along with TypeScript, and I'll be using Express.js as the web framework or the server, the HTTP server that will serve those API endpoints. But all the elements used in this video are the same across the board. So whichever framework you choose to use, the way the backend works will be the same. It's only a matter of adopting the principles and how it works to those particular frameworks. So as you can see here, I have a set of instructions that we're going to use to set up the project so we can get it up and running. So I'm just going to copy and paste those instructions in my terminal so we can have the project ready. And what I'm doing here, the first thing is to initialize Node. Please ensure that you already have Node.js installed on your machine if you're following along with Node.js. So you can head on over to nodejs.com and follow the instructions there as how to get it up and running on your system. So I'm just going to enter the package name, which is Flutter API, and it's just going to ask me some basic instructions that I can use here. And there it will create for me my Node.js application or scaffolding with the package.json file, and this file is where I will add all my packages and my scripts as to how the application must behave. So next I want to install TypeScript, but here I am installing it with the -d flag, meaning that I'm only using it for development purposes. So that is installed. Now I can install Express with the -s, which means to save Express.js as a dependency of this project. So this project has a hard dependence on Express.js. There we have that, and let's install the types. Since we are using TypeScript, we have to install those Express.js types so that we can have access to them. Now we have all those dependencies installed, and if we look in our package JSON file, we can see we have Express.js as a dependency, and then for dev dependency, which is the -d, we have the types and we have TypeScript. So now next what we want to do is to initialize TypeScript or the TypeScript compiler. So TSC's TypeScript compiler, we're just gonna initialize that, and that's gonna generate for us a tsconfig JSON file, so where we can configure how we want TypeScript to behave, especially when it's being compiled to JavaScript when we run our build. So there's not much to change here. I'm just gonna uncomment a few lines and add the necessary flags. In this case, for lib, I'm using ES 2015, and you can read the comment to see what that means. Further, I want to go here and allow these experimental features, since I'll be using some decorators as we go along. I also want to set the output directory, and this is the directory where the JavaScript file will be outputted when the TypeScript files are compiled. So we can put that there, and I'm going to say let source map be true. So that's it for our tsconfig file. We do not need to enable any other thing. Now the next thing is to install tsnode, and this will use this to run our server in development mode. And now that we have tsnode installed, we want to copy and paste this command here, and we're going to add it in our package.json file in our scripts. So inside of our scripts, we want this command, which is to access the tsnode package that we have just installed, and to set it up to watch our TypeScript files here, and then to compile the TypeScript automatically. So what this basically does is that whenever we made changes to our application, it will automatically restart the server to apply those changes, so that we do not have to constantly stop and start the server whenever we make changes. So now that we have everything set up here, let's go ahead and create a source folder, and here we have our source files, and I'm just gonna create a app.txt file. This is the entry point where our server will start. We'll set up our Express server, and we will look at how we access endpoints and receive HTTP request and send response using Express.js. And before we do that, we can head over to expressjs.com, and you can see the documentation here. If you are not familiar with it, you can go through the documentation. As you can see, it's a minimal and flexible Node.js web application framework that provides a robust set of features for web and mobile applications. And what we'll be using is mostly the APIs, which is the HTTP utility methods. We'll be using those to create our backend APIs. So now that we have Express set up, let us go ahead and import Express. Say Express from Express. Now we have access to the Express instance. We can go ahead and initialize our application. So const app equal to a new instance of Express. So now that we have Express there, we can now use that to access the different methods or APIs that's associated with the Express app. So let us now go ahead and set up the Express server or start the server. Use the listen method, and here I'm just going to pass a port. I'm going to use port 3000, and for the callback I'm going to say whenever the server starts, then I'm just going to print that to the console. So I'm going to say console log and say server started on port 3000. So now we have our app listening on port 3000 for requests. So now if we should go ahead and run that, npm run dev, and this dev is referencing our dev script here to run this command, then we should see that command run. Now we see server started on port 3000. We have not set up any endpoint as yet, so we won't be able to access anything on the server even though the server is running. But before we configure some of the endpoints, we want to go to our extensions marketplace, and I want you guys to install this extension, Thunder Client. So this is basically a REST API client for VS Code. So we're going to use that. It basically behaves like Postman, but instead of installing Postman, a third-party thing, and then moving outside of VS Code to use that, we're just going to install the Thunder client here, and so we can use that. And when you install Thunder client, then you will see this icon here. And if you go to that icon, you can see, as you can see, I've already made some requests. You can say new request. Then you enter the endpoint to the server, which is HTTP localhost 3000. Now if I click send, then as you can see, there is no get method being executed on that endpoint. So now if we go back to our app, now here is where we can configure the different endpoints that we want to allow HTTP clients to access so that we can return resources from our server to that HTTP client. And we'll be looking at the 4 basic HTTP actions that are widely used. There are about 6 or 7, but we mostly use the get action, the post action, the update action, and the patch action. And we're going to look on those actions and what they represent. So we have the get action, and this is basically our read. So if you ever hear the term CRUD, which is to create, read, update, and delete, then each of these HTTP actions would represent one of those, the CRUD acronym. So we have our read, and if I should do it in the CRUD format, then we would have the post method which is create. We have the read method, which is get. Then we would have the put method, which is update. But the thing with the put method is that it's not only updating, for example, an attribute of some resource you might have saved in the database, but what update does, it replaces the entire resource while maintaining the unique identifier or the primary key. So this is replace. Then we have patch, which is not used as much as put, but patch updates, but it modifies. So instead of replacing the resource, for example, if you have a user in your database table, instead of replacing that, the entire user itself, what patch does is to update a single attribute. For example, you might update just the name on that user. And then we have the delete action. Again, it deletes. So as you can see, create, update, create, read, update, delete, and that's the CRUD acronym. And as I said, we have other methods like options, and we have like head, but we're not going to look in those since those aren't used as much. But we have the head where you can request header information from the server, and options where you can request metadata information about the server and what to expect. And I think these are used mostly in streaming services when you can get information about the resource on the server, how large, how big that resource is, so you can determine how to download that resource. But let us go and work with these 5 methods here. So inside of our Express app, if I'm going to work with the get method first, I can say app, and there's the get method, and what it takes is a endpoint or a path. So that's the root path, and I'm saying when the user accesses or make a request to the root path, then what I want to do is to say this is the request handler, and this request handler will accept or will receive as its parameter a request object and a response object. So these are given to us by the Express framework itself. So when they access the get method using that root path, then the HTTP request is sent and a response object is also sent. That response object is what we use to return or to send information back to the HTTP client from the server. So for example, we can say response.send hello from server. Now if we should go back to our request here, and we should access, we should say get, because this is the action that we're calling from our Thunder client here, and which is the HTTP client. Then if we send that request, we should see hello, that's the response, hello from the server. So we know that we have that working, but to get more involved and so that we can add some information to a database and retrieve information from a database to demonstrate how the other methods work, what we're going to do is to actually connect to our database In this case, I'm going to use Postgres SQL. If you have any other database client installed on your machine, for example, MySQL, MariaDB, MongoDB, whatever the case is, you can use those database, and we're going to connect to them using the typeorm. We're going to use that framework to make it easy to connect and to retrieve records from the database. So here inside of our README again, we're going to look at how to set up typeorm. Let's go ahead and stop the server for now. We're going to copy and paste these instructions. So I'm going to copy. Again, I'm installing the typeorm package, and I'm using the -s as meaning this must be saved as a dependency. I also need to install this reflect metadata since typeorm uses reflect metadata. Let's go ahead and do that. I am using Postgres for my database, so let's install the PG package as well. And I'm going to install the necessary data types. So now we have that installed. And let us head on over to the typeorm website to see what that is about. Now, a ORM, or object relation mapper, is basically a construct where your objects in your code, for example, your classes that represents objects like a user, is mapped to database table. So if you have an user object, the ORM maps that user object to a database table, and it provides abstraction on top of the database technologies so that you will not have to manually write a bunch of queries. Now, even though ORM provides a simple way for us to interact with the database without having much knowledge of how SQL work and that kind of thing, it is still important to know at least the basic knowledge of what SQL is, how SQL works, so that in cases where you need to optimize, where the ORM might not provide the optimal response you want, then you know how to write your own queries to access the underlying database technology and to make those queries more efficient. But for the most part, ORMs work well. It helps us to develop quick. You write code, you write your database classes, your objects rather, as classes in your code. Those are mapped directly to the database as tables, and so you don't have to worry much about what is happening on the database side of thing. And typeorm is one of the popular ORMs that is used with Node.js. There's another one called Sequelize, but I'm more inclined to use typeorm. And as you can see, it's highly influenced by other ORMs such as Hibernate, Doctrine, and Entity Framework. I think Doctrine is PHP and Entity Framework is .NET. So as you can see, some of the features that's here, it's given. We have entity managers, we have repositories and custom repositories. There's a bunch of stuff here in the documentation that you can read if you're interested in learning more about typeorm and even ORM on a whole. You can read more and see how they work and how they can help to speed up your development time. So now that I have typeorm installed, What I need to do is go ahead and configure it to access my database. So what I'll do is on the root of my project, I'll create a orm config JSON file. And I already have this file, so I'm just going to copy and paste the information from it and then explain it to you guys. So here's my typeorm config file, and as you can see, the type represents the type of database. In my case, I'm using Postgres. Again, because I have Postgres already installed on my computer. If you are using MySQL, then you can head on over to typeorm.com. You can go through the documentation and see how you would configure MySQL, because it supports a plethora of database technologies. The host I'm using is localhost, and the port for Postgres is 5432. I have already configured the database, so the username on my database is test, the password is test, and I have created a database, an empty database called test. And as you can see, I have synchronized true and login false, and then here is where it's gonna search for the entities to map those entities to database tables. So you want to specify the location to your entities and also your migrations, even though we'll not be looking at migrations in this video, since the purpose of this video is to focus on creating an API and how HTTP server works instead of the underlying database technology. So now that we have typeorm configured there, in order for us to get typeorm running, what we need to do is to, inside here, when our server starts, I'm going to make this into an async function, and once the server starts, I'm going to create a connection, and this is imported from typeorm. This should come from typeorm, not net. So you see, we create a connection there, which this create connection uses the orm config file to establish the connection to our database. So now that we have that, I am going to use the create method, which is the post HTTP action. So I'm going to say post, and here the path to create a user will be user, so it will be /user. Now for the callback, which will receive a request and a response, here is where now we can create that user. So inside of source, I am going to create a folder called entity, and in entity, I am going to create my user entity. So this is now where we use typeorm to create the user entity, which will create a table inside of our database with the fields as columns in the database. So if I say class export class user, I am going to extend base entity from typeorm since it's an entity, and also we'll go ahead and decorate it with the entity decorator from typeorm, and now we can add our fields. So let's go ahead and add a ID field, and this will be a number or undefined I'm going to make this read only, and then I am going to tell typeorm that this should be a primary generated column. So this is like an identity column in the database, if you understand or if you're familiar with database terminology. So it's an identity column, meaning that it will auto increment each time a new user is added to the table. So that's the primary key. Then I am going to ask for the first name. This is going to be a string. And I'm going to say this is a column. And I'm just going to copy that and have last name and also I'm going to add a number for age. So now that we have that, we can, inside of our constructor, we can go ahead and accept those. First name, string, last name, string, and the age is a number. Then we can go ahead and call super for the super class, and then we'll set the fields for our class. In this case, set first name to first name and so on. So now we have our user entity. We can go now to our post method and we are going to create a user. So let us say const user equals user, and then for this user we are going to extract the information from the request object. So we are going to say request body, and the request body should have a first name. This request body is what is being sent from the HTTP client. In our case, our Flutter application will be sending over these informations to create this particular user. So we have the first name, then we have the last name, then finally we have the age. Let us import the user. This should be new user. And now, as we have this here, it would not work since the request would not know how to parse the body. So in order for us to tell the request how to parse the body, tell Express how to parse the request body, we need to go ahead and tell Express to use, and here we're going to add a middleware, which is basically an action or a callback that is executed before our final request callback. So it's executed before this method. So it's executed and then it transforms the request object so that when the request object finally reaches this method, the data is as we expected. So I'm going to say use, and in this case, I'm going to say express.json. So it's a JSON body. So now all I need to say is to say const result equals to await user save. Then I am going to say response dot JSON the result from saving. So this save is responsible for saving the user data to the database. Just make this method async so that our await there can work. So now that we have that, if I go to my database table here, as you can see, I have my public user table, and I have, if I execute a select statement, then you can see no record is found. It's empty. Now, if I go to my request and I say request user, and inside the body I'm gonna have a JSON object with first name John, last name Jones, age 33. Let us go ahead and start our server. npm run dev. Now if I send this request, then I am having error. So there is something with the JSON here, which is a missing semicolon. So let's go ahead and run that again. As you see, we cannot get this endpoint because we are using a get action here instead of a post action. So let's change that. Let's run that. As you can see, a user is created with the ID being 10. And if we should go back to our database now and run the query, then you can see that user is added to the database. That's it for our post method. So we are able to create a user. Now we can use our get method to get the user. So in this case, we are going to say user, and we want the ID as the parameter. So now when that request comes in, I can say const user equals to await, and if I make this async, then I am going to use my user entity, which is my typeorm entity, and I'm going to say find one. And find one, I'm just gonna get the ID from the request object. In this case, it would be in the request params ID. And then I can say if the user is undefined, then I know the user doesn't exist, and I can simply return and say response send user not found. Otherwise, I can simply say response JSON and send that user object back to the client. Now, if I go here and I say, okay, I want user 1. Let's try that. Again, let's change it to get method. then we should see user not found. If we enter 10, then we should retrieve the user from the database. So now we have our create method, our read method, our post and get in terms of HTTP actions. Now we need our put method. I'm just going to copy here, change this to put, and again, put uses the ID that we need to replace and also fetches the information from the body. So again, I'm going to try and find the user. If the user doesn't exist, return the information saying the user not found. Otherwise, if the user is found, then I am going to update that user. In this case, I'm going to say user first name is equal to the request body, fetch the first name value from it. Let's go ahead and copy that down. Do the same thing for the last name. This should be last name, and user age should be the request body. Let's go ahead and fetch the age from that. Then now that we have the user, we can go ahead and save that user. So we say user save, and we'll pass that into the result, and we'll return the result to the HTTP client. So now, as I've mentioned before, put replaces the entire resource. So even if you do not pass a first name or last name, for example, let us go ahead and test that out. If I pass only the age to say change the age to 36, it will change the age to 36, but it will replace the entire object. So now what we're going to have a case where the first name and the last name is empty. So let's go ahead and run that. Let's check our database. Okay, we should change this again to put instead of get. Let's run that. See, an empty JSON is returned here. Let's check our database to see what's happening. The user age is updated, but we have an empty JSON here. Why is that the case? So the user is saved, meaning that the user is updated, but the response is empty. Let's add back the first name here. Hey, let's send that. We're still having an empty response, but inside our DB we can see where the field is updated. Okay, I can see what's happening here. We need to await for the promise to complete. So now let's try that again. Go ahead and run. Now we see first name, age, 36. Let's check our database. We see that there. Let us change the name to Jackie. Now the first name is updated to Jackie. So now if we copy and paste this to our patch method, let's change the action to patch. It is the same thing. So now if we go to our request, we change this to patch, change the age to 22, then we get the same result. Jackie 22. And the thing also is that with put can also be used to create a resource if it doesn't exist. So, but it's not used in that way oftentimes. And in this case, it wouldn't work because I am saying that we should return if the user is not present. Now for our delete action, it is pretty simple. We go ahead and we say app delete, and there we have our delete method, which is to find the user based on the param and simply remove the user. So if we go here, we say delete number 10, then number 10 is gone. If we look inside of our database, then it's empty. There's no longer any number 10. So these are the foundational HTTP actions that are used with any API, any request that we make in terms of creating our backends and accessing resources. Now, we can make this more modular by adding the routes here to a file, because it wouldn't be possible to have every single route in the app.ts file. We could go ahead and we could create a router, and then inside of the router we could say we could have user routes here, then we go ahead and create a express router. So I'm going to say user routes equal to router from the express package, and we simply copy and paste all these routes here. Let me go ahead and cut them, paste them here. But instead of using app, I'm gonna say use routes. So let's go ahead and change all these, change it to user routes. And then what we need to do is to simply say now we can go ahead and export user routes. So now inside of our app file, we can go ahead and say app use, and then we simply say use user routes. So now if I go back to our request and see get user not found, let's go ahead, post, let's create a user. Remove the ID. There we have our user created and our user added to the database. So we can clean up our TS or app or entry point file, and we can have each route separated. So you can imagine if you have other routes for other modules, for example, photo routes, then you will add them here, and then we'll simply tell the app to use those routes. So this, guys, is a simple introduction to how HTTP servers work, how you can create a simple one using Nodejs, Express, and typeorm to connect to the database fast and to perform the basic HTTP actions. Now, if this is something that you like, then we can continue this video. We can make this a series where we look more into backend, more into making this into a more full-fledged backend, that we can learn more about the whole dynamics of creating our own backends. So thank you guys for watching this video, and please do like, please do share, and subscribe if you haven't, as we strive to become better Flutter developers all around. So thank you guys, and see you in the next video.